In this video, I'm going to show you guys how to use the standard normal table. In order to use the standard normal table, you need to have a z-score first, and then you need to know which area of the curve you're interested in. So in each of these examples, we actually know a z-score, and then we've been told what area we're looking for. We're looking for the probability of a z-score being less than negative 1.42. So I like to draw these things out just to visualize, to make sure I didn't have any simple errors here. Z-scores are centered at 0. We know that their standard deviation is 1. So if we kind of think about how this thing is spread out, it's going to look something like that. So negative 1.42, if I want to be very exact about it, it's going to be right about here. And of course, when I say very exact, it's not, because this normal curve is a little fatter than it should be. But this is what we're looking for. Area under the curve, right? Probability translates to the area under the curve for a particular interval. So z being less than negative 1.42 corresponds to that section of the curve. Now, the table I like to provide is a left-sided table. If you need one, come to my office and grab one. I have a ton of them. Don't go looking online unless you're Googling with left side probabilities, because you'll find online tail probabilities, middle probabilities, right probabilities. But I like left probabilities, which is exactly what we're looking for. So I know I handed out a table that was, this is thinking about opening. Maybe. Okay, we'll open that. Why won't you open this? You opened it earlier. Oh, it's really small. All right. The table I gave you guys in class had two sides, which actually made it a little bit easier. So you had all your positive z-scores on one side, all your negative z-scores on another. This is an older table I have, which manages to fit them all on one page without the cute drawing at the top. So if I'm looking for a positive z-score, I'm going to the positive side of that sheet you guys have. And we were looking for, sorry, I've got to look at it because I can't remember. We're looking for negative 1 point, why did you jump down? Negative 1.42. So if I go back to this, I actually need to be in the negative side, my goodness, negative 1.4. And then the way this works, it's sort of like a stem and leaf plot. At the top of the table, and in the middle of this one too, you have the first two digits on the side, and then at the top you have the final digit, the hundredths place. So you're going to look for negative 1.42, and you're going to see where those pieces intersect, and that's the corresponding left side probability. So 0.0778 is my answer. So this probability is equal to 0.0778. The reason I like to draw my little picture is I can look immediately and say, yeah, I shaded something pretty small. This looks about right. And if I really wanted to get into this and check it, I could think about the empirical rule. For the empirical rule, we knew there was what? My brain is trying to do math in its head right now. 68, which leaves us with 32, 16% out in this section after 1. So it's got to be less than 16%. At 2, it was something else that I can't think of right now off the top of my head, 2.5%. So somewhere between 2.5 and 16%, and we have about 7.8%. This makes sense. So the next one asks us the probability that z is greater than 1.95. So 1.95 is going to be on the positive side. And we have the greater than telling us we want to shade here. So here's where we get in trouble with our table. And we have two different options if we want to do things with the table. One option is we can just look up 1.95. So if I do that, go to my table, positive 1.95, gives me 0.9744. But that's the left side, which is completely okay, because if we know the left side is 0.9744 and the whole area under the curve is 1, our probability is just 1 minus 0.9744, or 0.0256. So that's one way to do this, is think of, okay, I can't get the right-hand side. We're going to treat it kind of like our binom CDF stuff. If ever I shade the right-hand side, I'm going to do a 1 minus if I'm using the table, because the table can only give left-hand sides, just like binom CDF could only give left-hand sides. Another method, so this is method 1, is just 1 minus probability of z less than 1.95, right? The table. Method 2 is to use the fact that this curve is symmetric. So we can look at this and we know, okay, if I'm looking for the probability of greater than 1.95, that's got to be the same thing as a probability of less than negative 1.95. So you could just look up the negative anytime you're dealing with the right side. So again, if I had gone to my table, negative 1. Oops, that's not 1.9. Negative 1.95 gives us out that 0.0256. Really, again, if you have this drawing, it makes it really easy to not have any mistakes because you're never going to give me out 97% of the curve when you shaded this tiny, tiny piece of the curve. So that kind of lets you know whether you're looking at the positive and the negative. As soon as I see that I shaded less than half the curve, I know I have to be on the negative side of things. The last probability here that we could use for the table is a between probability. So now we're looking for the probability that our z is between a negative 1.02 and a positive 2.57. That should probably be way over because it's almost to 3, which is the end, 2.57. So we got that. If we're thinking about that empirical distribution, we have the 68% that was in between the two, and then we got some more. So this is looking like a big probability, right? That's what we're looking for. And this is one where if we're using the table, this is a heck of a lot more than using the calculators. We're going to have to look up 2.57. All right, so look up positive 2.57. 2.5, that is not positive, my goodness. 2.57. And don't just count over, there is a 0, so you want to make sure that you are actually looking at the top and drawing all over your normal table if you're using it. 0.9949. So 0.9949. What we just found is everything under that 2.57, that entire area under the curve, which is too much, right? In fact, we know exactly how much it is too much. It's too much by this section right here. So we also need to look up the negative 1.02. And there are lots of other ways to do it. I've had students before look up these two tails and then subtract that all from one. This is just one method. There's a lot of them. So I'm going to look up negative 1.02. Which gives me 0.1539. This is the extra bit too much that we counted, right? So I'm just going to subtract those, and that's going to give me the correct value that is in that shaded region. So 0.9949 minus 0.1539. So 8410. Boom. But like I said, I personally don't think we need to be using the tables at all. We have our calculators. That technology will do the same thing for us. The graphing calculator I'll show you in the next video. And the little calculator works exactly the same. So if you're using the TI-36X, you're just going to go to your distribution section and use normal CDF just like I did in mine. In fact, it's almost easier for you guys.